we'll spend some time taking a look at the homework itself, the assignment, and discussing midterm. Okay. You want extra class tomorrow? What do you want for it? What do you want for extra class tomorrow? What do you want? You have to specifically tell me. See, you asked me what specifically you want, right? So you have to specifically tell me what you want. You cannot just say review. That is where you limit, where you don't know what you want, and you just ask a general, and it may not be relevant. If you want tomorrow's, then we won't discuss anything today. We'll just move on with the actual syllabus. Don't focus on MATLAB for now, because I don't think it's, you have to focus on midterm. Not now, Anton, not now. We'll do it later, yeah. You want to do the review tomorrow? Yes, office hours are always open. We'll meet again tomorrow at 1. What we'll do today is, I'll just get you a head start with what's tomorrow. If you have any specific questions, we can address. I'm not going to do anything general. If you have specific, then I'll address those. Okay? So first, if you look at the assignment, what is your first? Have you had a chance to take a look at the assignment? No? None of y'all? Huh? Somewhat. All right. So the first question is, it's just a direct, it's a very simple derivation. Okay. What you need to focus on, or what you need to know in the first problem is, we'll we'll spend some time tomorrow as well, but tomorrow what we'll do is I won't give you any generic tips. We'll just, I want you guys to attempt as many problems as possible by tomorrow. And if you have any specific questions, you can ask. So the first question is about conservation of angular momentum. Okay. If you understand conservation of angular momentum, you will attempt. Now, many of you are just going to look at the textbook and copy what is in the textbook. That is not going to help. Okay? It will put you in more trouble if you do that. What you need to do is you need to learn how to take a cross product. Okay? If you do just copy from the textbook, you will be in serious trouble for the exam. All right. So these two are the main concepts you need to focus on for the first problem. The second one, we have done this in class. Okay. We have done this as an example. We have not done this as an example. We have gone through the process of finding H, A, I, omega, and some of you have already done your MATLAB thing. Now, what you should be doing here is look at the units. Okay, the units are SI units or MKS units. You know what SI units is? No? Okay. MKS? No? It's meters, kilograms, and seconds. Okay. So the units are SI units. Okay. It's kilometers for distance and kilometers per second for velocity. Look up mu, value of mu. This mu. What does this mu denote? No, what does this mu denote? Right. So geocentric means Earth-centered. So this is the gravitational parameter of geocentric, Earth as the central body. So you need to look up that. Okay. This unit, you're going to find it in canonical units, you're going to find it in feet, you're going to find it in MKS. So you have to look up what is relevant for this. In exam, you'll be given this value. Okay. You will be given the mu value. You don't have to worry about the mu value. All right. So look up this, and everything else should simply follow. Now, for your midterm, in your formula sheet, write down the process for orbit determination. For orbit determination, this is orbit determination, right? This is, You can write down the steps. All right. third one is what we covered in the last class on Friday. And this is where your midterm syllabus ends. The transformations, coordinate transformations, okay? This is, see, this transformation you're looking at is really simple. Trust me, it is really simple if you understand it. Okay? What is the transformation? What is the rotation sequence, first of all? What is the rotation sequence you see? Look into this thing and tell me, do you have a copy of the homework? No? Do you see the rotation sequence? Three, 1, 3. Okay. It's a symmetric rotation sequence. We'll discuss what symmetric rotation sequence is, but it's a 3, 1, 3 rotation sequence. About what angles? What are the angles? Omega, I, omega. Okay. Can you see those angles? Okay. All you need to do here is you need to write down the DCM for fundamental rotation. So if it's a rotation, it's a 3, 1, 3 rotation by angles cap omega, I, small omega. You need to figure out the fundamental rotations for 3, 1, 3 by those angles and multiply those matrices in a particular order, particular sequence, and you're going to end up with that. Now, some of you are going to skip steps here. You're going to just show the multiplication, put the matrices in there, and say this is the answer. You're going to lose more than half of your points if you do that. Okay? Because it shows that you don't know what you're doing. So what you need to do is you have to show that there will be 3 matrices involved here. You have to show the multiplication of every matrix. So you'll end up with, when you multiply 2 matrices, you cannot directly multiply 3 matrices, correct? Can you multiply 3 matrices at a time? So you multiply 2 at a time. You need to show the output of 2 matrices. If you just write the 3 matrices in a particular sequence and then say this is equal to this, you're going to lose more than half of your points. And if the sequence or something is incorrect, you're not going to get any points. All right. The fourth one is fairly simple. I think this was given as your practice first exam, right? What does RPVP stand for? RPVP and RAVA? Apoapsis. Okay. So what is periapsis? So what does periapsis mean? What does periapsis mean in this context? What is true anomaly at periapsis? Huh? Right. What is true anomaly at apoapsis? Huh? 360 and 0 are the same, right? See, this is what you don't, you're not able to understand. If you don't understand this, then it's serious trouble. You don't understand, you're not able to visualize orbital mechanics at all. Yeah, it is simply 180. And at this stage, if you're not able to visualize, then you're in trouble. You're not keeping up, and it may end up in a fail grade. Okay. So you do that, you very easily end up with these two. Okay. The second part is you just substitute one of those, to show that size of the orbit defines energy. What is energy here? No, what is energy here? You're not following. Many of you are not following this, because yeah, what is energy? So many of you see, this is what is happening. You're not following very basic things. So this is energy, and you need to show that. What is the size? What do you mean by size? No. Eccentricity defines shape. Size is defined by the semi-major axis, right? So semi-major axis defines the size, and that's what you need to show, that this epsilon is only a function of semi-major axis. Okay. All right. So there's a typo here. This is 30 degrees. Okay. It's not 300. So if you look at this one and this one, fifth and the third problem. (30, 60, and 90 degrees). So what are the rotations you see here? So this was a 313 rotation, right? Which rotation is this? Read and tell me which rotation is this. 1, 2, 3, and by what angles? Right. So you're able to connect now, right? Everything is about either one of those axes. Okay, it's 1, 2, 3, always 1 or 2 or 3, and the rotations, the fundamental rotations for those axes is pretty well set. It is always, we have looked at those 3 fundamental rotations. It's a very basic matrix. Right? So what you're going to end up is, you're going to end up with something like this, a 3 by 3 matrix. But each cell is one number. each cell is one number, because these are now values. So it will be cosine something, that number into this number minus this number into these two. So it will all end up as a one single number. So this matrix, you're going to see this matrix as a 3 by 3 matrix. All right. What do you need to do with those with that matrix? This R is in what frame? There are two. First of all, try to understand that there are two reference frames, okay? Right, there is an IJK frame. Now let this be IJK. So you have I, J, and K, right? And you have U, V, W. Okay. We looked at this, right? Last class, if you were present, we looked at how we go from IJK to U, V, W. And that is what you're going to do here. If you do the transformation for 1, 2, 3 rotation by those angles, you're going to end up with that matrix, which will take you from this to this. Okay. Now you have a vector here. This is a vector R. Okay. What frame is this vector in? Why? Yes. Now that is good learning. Just if I ask you just where this vector is, you really don't know where that vector is. Okay. It could have, this vector can have components in IJK, right? It can have components in IJK. It can be expressed in IJK. So what you're seeing here is that vector expressed in a particular reference frame. Got it? So it's difficult to visualize in 2D, 3D, but if you look at this, if there are two of these, okay, these two reference frames, which are x, y, and small x, y. And if you look at this vector, this can have a component in this and this, right? But it can also have component in this and this. A vector by itself is independent of a reference frame. Vectors are all mostly free vectors. They can be expressed in a reference frame. And that's what we are doing here. This vector R is expressed in IJK frame. Okay? If you have a vector expressed in RJK frame, this is how you write it. R, you can either write IJK equal to what do we have here? So you have vector R in UVW is equal to C So you see, you know this, right? What is this? Vector R expressed in IJK is what you're seeing there. 2I minus j plus 4k. The components in ijk are this. Okay. This, what is this? The transformation matrix. The transformation matrix which transforms ijk to UVW. You read it backwards. It's just a notation. You don't have to. This is what we use. We want to use. Okay. So it is read as transformation matrix or direction cosine matrix, which transforms the ijk frame to UVW frame. So if you take a vector in R, what is the dimension of this vector, or what is the order of this vector, of this matrix? Yeah. You express vector, if you express vector as a matrix, how do you express vector as a matrix? You have 2 minus 1, 4, right? So it's a 3 by 1 matrix. Vectors are always column matrices. Vectors always have to be expressed as column matrices. So this is a 3 by 1 matrix. What is the order of this matrix? Huh? There is no first order matrix. It's a 3 by 3. That's what this is, always a 3 by 3. A transformation matrix is always a 3 by 3. That is what we looked at here, right? It's always a 3 by 3. So if you multiply 3 by 3 into 3 by 1, what are you going to get? Huh? It has to be 3 by 1. Because see, this end product again, this has to be 3 by 1, right? So this 3 by 3 into 3 by 3, you have to, you guys keep forgetting everything. I don't know how. So if you do that, always this happens. Okay, the inner thing cancel out. So you get always end up with the outer. Okay, and the check for whether a two matrices can be multiplied is the number of columns in the first should be equal to the number of rows in the second. So you cannot do this. This is not defined. So don't do this and say 3 by 1. These two have to be the same for a matrix to multiply. Okay? So you end up with 3 by 1. This is vector expressed in, the same vector expressed in UVW frame. It's just that these components are UVW components. Okay? Got it? Sixth one is fairly simple. We have discussed that in class. The seventh one, I have given you transformation. How do you transform from equatorial frame to lat long or right accession declination? Right accession declination is lat long, right? You agree with that? What is the difference between right accession declination and lat and longitude? What is the difference? No? Forgot? right accession and declination or lat long are actually on the surface of the earth, right? Those are imaginary lines on the surface of the earth. When you're talking about right accession and declination, that's an imaginary sphere or a celestial sphere, that's what we call, which is outside, which is actually an orbit, right? That's what we said. You remember? Do you get it? Do you at least understand it now? It's your latitudes are measured on the surface of the earth, right? Your latitude and longitudes. So you have latitudes are lines running from east to west, but they are measured in north latitude, south latitude, right? Longitude are measured east longitude, west longitude, but they are lines running from north to south. Those don't have anything to do with orbit, right? Because they are on the surface of the earth. Your right accession and declination are measured in a celestial sphere, which means, see, if this is Earth, these are your longitudes and these are your latitudes, right? You have equator to measure your latitudes. You have the GMT, the meridian, to measure your longitudes, correct? When you're measuring your right accession, you have the celestial sphere, an imaginary sphere around Earth. Because you're trying to measure orbits, right? So from starting, you extend this meridian in this orbit. Now you can measure it in right accession is this, because you're doing this right accession. And declination is you're either going up or you're going down. But it's for the celestial sphere. Celestial sphere it's an imaginary sphere around celestial sphere. Celestial. So another name for this course is celestial mechanics. Celestial mechanics, orbital mechanics, astrodynamics, space mechanics. So this is the celestial sphere. Okay? Celestial sphere is an imaginary sphere around Earth, where essentially your satellites or other orbiting bodies orbit. Okay? The right accession and right declination are just measured for this celestial sphere. Now you need to understand there's a very simple transformation which will take you from geocentric equatorial frame to right accession and declination. Now this is a hint for you to write down that transformation as a formula for the midterm. Get it? No? This is a hint for you to write down that formula. All right, the next one, we have discussed what eccentric anomaly is. You will not draw this figure of what eccentric anomaly is as part of your formula sheet. Okay? So you will be asked to do this again in exam. You may be asked, you will be. At that point, you need to understand what this eccentric anomaly is. It's a very, very simple angle. Okay? So go back, go to the textbook, and try to understand what this eccentric anomaly is. And you have to you have to be able to derive the relationship. This you cannot note down in your formula sheet. This is a very strict warning. All your formula sheets will be attached to your exams. And if there are any derivations, you will not receive any credit for midterm. Okay? And I check the formula sheets very thoroughly. So if there are any derivations, you will lose all your credit for midterm, and you will not have a chance to retake the midterm either. So a big percentage of your points you will lose. All right. Similarly, you have to relationship between mean motion and mean anomaly. What is mean motion? Do you guys remember how we define mean motion? Mean motion is the average angular velocity. You understand angular velocity, right? You understand angular velocity? No? You understand angular velocity? You don't understand angular velocity? Don't think of the formula. Just describe to me what angular velocity is. Huh? If you look at your wheels, right? For example, if you take one point, this is the angle made by that point, right? And this is theta. This is the angle. The change in angle as with time. That is your angular velocity. Now, what happens in an orbit? In an orbital, if this is a circle, the angular velocity is the same, right? The rate is the same. It's moving at a constant speed. For an orbit, since it could be an elliptical orbit or a hyperbolic orbit, the angular velocity varies. That is one of Kepler's laws, right? The angular velocities, it has to trace equal areas in equal times. So if it's far away, the angular velocity is much smaller, right? If it is at the apoapsis, the angular velocity is the smallest. At periapsis, the angular velocity is the highest, because it has to trace much more area in that time, so it has to move fast. Now, when you average that angular velocity, when you take the average of that angular velocity, you get what is called mean motion. Okay? So you have to derive a relationship between mean motion and mean anomaly. Got it? So that should conclude our discussion for. Please attempt all these problems, especially the numerical problem. And if you have any questions, I want you to ask tomorrow. I need attendance. Here, Lowell, hang on, just a minute. Keep in mind, none of you have passed the first test, okay? Yes, that's your assignment 2, right? mentioned that in my emails. I'm going to repeat it. It's recommended that you turn it in before the midterm, but because at least do it before the midterm, even if you cannot do it, turn it in. But the due date is Friday. The actual due date is Friday, okay? But try to do it before you. Sammy, you're not going to get attendance. You came after the class ended. Malcolm. Okay. Did you sign your attendance? Okay.